All right, welcome everyone to UTA Planetarium's Ask an Astronomer. My name is Jim Bader. We have a different show this week. Things are a little bit different. As you can see, I'm here and not Levent. I'm usually behind the desk pushing the buttons, but today I finally get to take my mask off and be in front of the camera. So I'm glad to say I can breathe. I'm just kidding. I can breathe in a mask just fine. But we have a fantastic program for you today. Sadly, we didn't get to see we don't get to have Levent here. He had some other things he had to take care of today, but we're going to be consistent. Hey, Brexton, how's it going? Will we see more pictures from Mars? Not today. We'll talk a little bit about it. We're mostly going to talk about the Voyager spacecrafts. I'm super pumped to bring some of this cool information to you guys. We have some interesting things to talk about, and this is kind of a transition. Levent and I were talking about what we were going to say and how we were going to move forward after Perseverance, because, I mean, all the new stuff coming out about Perseverance, we could do shows every week about the new data that's come out and the new images. And I think what's really cool for me is that a lot of the amateur astronomers, so some people, normal people, people like me and so many of the viewers that you guys watch, are downloading the photos from NASA as they come back from the orbiter, and they're learning, or not the orbiter, but the rovers, and they're learning all this cool stuff about the rovers, and then showing that to NASA. So this is a citizen scientist thing that they wish they could get to and do. This is super cool, though. I'm certainly excited about all the new stuff we're going to be learning. So we'll get back to that in the future, but we thought we'd transition, because what people aren't often saying, just like if you go to you watch a show, a theater show, something that doesn't happen anymore. That industry is currently on hold until the pandemic situation plays out. But if you went to a play, you get the playbill and you get to see the actors and you say, what a great job the actors do. But it's so often overlooked that there are other people involved, right? Who painted everything and who built everything and who wrote the show and so on and so forth, and all the other people that worked seamlessly behind the scenes. This same thing happens with rovers. You see the rover, all you hear about is the rover, but you forget that there are spacecrafts orbiting Mars that are collecting data from the rover. There's lots of other people involved and other things involved. We started thinking about other spacecraft, and it dawned we haven't talked about the Voyagers. So that's what we're going to do today. We're going to talk about the Voyager spacecraft and see how it goes. See if you guys like it. Some of my favorite spacecraft for sure. So a quick summary. The Voyager are a pair of some of the most successful spacecraft that have ever been launched into outer space. So in the summer of 1965, we saw an emergence of a couple of really important ideas happening at that time. One of the first one was gravity assist. This has been an idea that would kind of been theorized and is pretty, I want to say, simple in terms of mechanics and using gravity, I suppose. It was super complicated in actuality, but the concept is pretty simple. Hey, gravity pulls on stuff. We could use it to accelerate spacecraft. And that was shown to work with the Russian spacecraft, the Luna 3, in 1959. And that really teed NASA off, wondering how could we use this? Well, NASA wanted to learn a little bit more about the solar system. And so in wanting to do that, they decided to open a new program called the Mariner Program. And the Mariner Program really, we have a beautiful picture of the Mariner Program. Really what it was, the Mariner Program was just NASA's way of saying, hey, we want to explore the solar system. We're going to send off mariners, you know, like we have in the past, to go and explore each of these worlds in our solar system. So that's what they did. They sent off a handful of spacecraft. I think there was 10 mariners in all. Planned to be 12. We're going to get to that. And as they went through these spacecraft, a lot of interesting things played out. So first of all, they were launching on new rockets with the mariners, and they expected high failure rate. So NASA kind of doubled up on every one of the missions. So for instance, Mariner 1 and 2 were supposed to do the same thing. They were supposed to go to Venus and take photos. So they launched Mariner 1, and it failed on the launch pad. Not too great. Mariner 2, success. And we got a beautiful image of Venus, which we can show here. You're probably seeing that and thinking that looks like Earth. It does. This is UV or ultraviolet view of Venus. One of the coolest views of Venus, I think, ever. It looks super cool. The stripes, it looks really, really neat. Definitely one of my favorite photos of Venus. I think I like the ones with the clouds peeled away. Those views are fantastic, but we don't have any of those today. Anyway, Voyager 3, or sorry, Mariner 3 launches later, and it actually fails too. So Mariner 3 was not a successful mission at all. It didn't go well. Launched in the failure. We were going to explore Mars. Mariner 4, it was successful, however. It did. It made it all the way to Mars, and we showed pictures of that a couple streams ago, so it did really well. I think there was another failure. I think maybe Mariner 8 failed. I'm going to say the rest were pretty successful. And then Mariner 10 comes around. And Mariner 10 was going to explore the inner solar system. It was going to go hang out with Mercury and hang out with Venus. And we launched that spacecraft, and NASA had crossed their fingers hoping, could they possibly get this gravity assist right? This is the first time that NASA attempts gravity assist. Soviets had done it, but now it's turn for NASA. And the gravity assist worked so perfectly, they thought, hey, there was one other big notice in the mid-60s. They noticed gravity assist worked for the Soviets, and also there was this upcoming alignment that if gravity assist worked, we could explore all 4 of the gas giants with one spacecraft. This was a big leap. It worked for Mariner 10, so shortly after Mariner 10 launched in 1976, 77, NASA renamed the Mariners 11 and 12 to the Voyager program. And that's how we get to where we are today. Anyway, Jennifer is helping me in the background. You guys don't see her. She came in very last minute and is somehow pulling off a miracle in the backstage. So thank you so much, Jennifer, for helping with that. Really appreciate it.
You're very welcome.
Good. Let's jump into this. So Voyager begins. We got to back it up just a little bit because the planning for this, it was planned under Mariner 11 and Mariner 12, and they had to start somewhere, right? So Mariners 1 and 2 went to Venus, the closest planet. Then what's next closest? Well, Mariners 3 and 4 went to Mars. And what's after that? Well, we should go to Mercury. So that's where we end up with Mariner 10, so on and so forth. Goes to the inner solar system, but they still want to do the outer solar system. So those were Mariners 11 and 12. And they'd been planning to go to these. They originally just wanted to do Jupiter and Saturn. Obviously, that turned out we got whole lot more than that. And then in late 1972, we finally have the first planning for the missions happen there. Not until 1977, in August, actually the 20th of August, we get the launch of Voyager 2. It launches. That's right, Voyager 2 launched. And then 3 weeks later, or a little over 2 weeks later, we actually have Voyager 1 launch, which doesn't make any sense. And you might think, was there a launch failure or was it delayed to weather? And these are common things tossed around. But the naming system really comes that Voyager 1 was going to be so much faster and it was going to get to Jupiter first. So they thought, we're going to launch these, some people are going to watch it, but it's going to be really hard to explain to the media, hey, Voyager 2 has finally arrived at Jupiter. And then 4 months later, Voyager 1 has finally arrived. So they decided to name them in a different order. So Voyager 1 arrived at Jupiter first 4 months earlier, even though it launched a little over 2 weeks later. Different path for both of them. They took totally different trajectories. We actually have an image of trajectories I think we can get up. Right, maybe it'll take just a moment to show these trajectory images, but super neat. Yes, you can see the trajectory images here. Anyway, in the center, we have the inner planets. You can see the launch dates there. It has 2 different launch dates in circles. Those are, okay, I can point to them now. This is the position of Earth. Stuff's moving, right? So anyway, they launch and then they go to their places. So Jupiter, Saturn, and you can see trajectories were totally different. Voyager 1 way out here, and Voyager 2 dropped below the plane of the solar system and left the solar system in a little different pattern. Anyway, let's talk about where do they go first, right, Jennifer? Where do they go first?
All right, let's see.
You guys, I mean, you should guess this. This is Jupiter, right? They went to Jupiter first. So we can show some of our first photos of Jupiter. Voyager 1, as it arrived to Jupiter, it did something that hadn't been done before, and I wish we could have located this clip for you, but this will have to suffice. Because for me, what is so important and like emotionally binding to the Voyager spacecraft is the images that they took were the first like good images we had of so many planets. And because, or at least all the outer planets and all the moons that we looked at with that, these were huge missions. The amount of data and information they got back came up with so many questions that later spawned spacecraft like Cassini and Galileo. These spacecraft studied Jupiter and Saturn. And even gave us more reason to send stuff like New Horizons to visit Pluto. I don't know if you guys know this, but they were gonna send Voyager 2 to Pluto. It was something that was in the possibility they could have, but instead they decided to use that fuel to stop and study Titan, which we'll get to in just a moment. Anyway, hitting up Jupiter, Voyager 1 was really more of a flyby. It just kind of popped in, saw a couple things, and passed through. So while it's at Jupiter, it actually discovers 2 moons. It gets images of the crazy volcanoes on Io. You guys may have seen images of that before. And then it moves on to Saturn. So once it gets to Saturn, it actually discovers 5 moons on Saturn. It also discovers another ring of Saturn. And one of the neatest parts about Saturn's rings is people don't often know this. There's like little satellite moons, like little tiny moons that are around the outside of the rings, and they really, the term they use is shepherding. They kind of hold the whole ring system together. Brexton, we have a question from him. He says, after they finish their missions, do they return to Earth, or are they just floating out there? We're going to get to that. This Brexton is actually what blows my mind about this mission, or the Voyager program in general, is what happens after they finish those most basic missions. There was a plan. NASA expected that. That's going to be kind of the end cap of this for sure. Either way, yeah, so it leaves, goes to Saturn, like I said, discovers some moons, sees these cool shepherding things, adds another ring. In reality, it just adds another separation barrier between it. And it notices there's some questions about the rings. We see some stuff we didn't really know about before. Things called spokes. It was like a weird ring area that had like spokes. It looked a little bit like spokes on a bicycle wheel, and they didn't understand what these properties of the rings were. We'll get to that with Voyager 2. It gets quite a bit more interesting. And then they see Titan. And Titan, they see this super dense layering of clouds that we haven't seen anywhere else in the solar system. And this is something they are just blown away about. And when they get to Titan, they notice, hey, with this much clouds, there might be liquid on the surface of this moon. The only other place that humans know of where there may be liquid on the surface of another body. So Earth, we have liquid water, and then Titan, we think there might be liquid, not water. We'll get to that. As it does, we learn a little bit more about it. Now we know that there's actually liquid methane on the surface, which is pretty neat, pretty fantastic. And then after it visits Saturn, Voyager 1 actually completely leaves the solar system. It doesn't turn off. It doesn't come back to Earth, Brexton. It just leaves the solar system. It's just on its way out. It's moving at like an incredible rate. I think it's somewhere close to like 40,000 miles per hour a ways after it leaves. Maybe Jennifer can confirm this while we're doing this. But I think it's something close to like 40,000 miles per hour that it's moving at. So it's booking it. I think it hit speeds of near 100,000 miles per hour at some point.
With velocity, it is going 38,000 miles per hour.
That's today. So
Yes.
38,000 miles per hour, that's just bonkers. I don't really like driving like 60 miles per hour, and 30,000, obviously, it's a little bit faster. So yeah, Voyager 1, its new mission was to leave the solar system. And we're going to touch a little bit more on that later, but we need to talk about one of the most spectacular images ever taken by any spacecraft, any human, anybody. It is just definitely, for me, one of the most moving images. In 1990, all right, it's well on its way out of the solar system. It turns around and it starts taking a series of photos. This is Voyager 1. And one of the photos is known, I'm getting goosebumps right now just talking about it. This is known as the pale blue dot. This is that famous talk that Carl Sagan gave over this. Suspended in a beam of light, you can see just this little tiny dot here. And it's just incredibly emotional and incredibly moving. That is every human who ever lived, everything that there ever was. I'm not going to quote him completely, the Carl Sagan quote there. We might get a link to that if Jennifer's really good to us. But it just absolutely fantastic. This photo shows just this tiny little speck. I'm a tiny little speck on that tiny little speck. It is the most connecting image for me ever. Yeah, it's just incredible, absolutely phenomenal. And after taking this photo, it turned itself, most of its components off. Not all of them, turned most of its components off, and it just continued on its way out of the solar system. We got an official, hey, you're out of the solar system in 2012. We got some readings that said that Voyager 1 was all the way out there. In 1998, Voyager 1 actually overtakes Pioneer 2 as the most distant man-made object. So Pioneer 2 or 10 was quite far, but Voyager overtakes it with that incredible speed, and now it has left it in the dust. We have an image. We'll get to that a little bit later. Crosses the outermost boundaries, and it's going to keep going as it is today. Probably, I think most of the estimates are that the fuel can't last much more than 2025. Like that would be, there's no way that it can continue going. I think 2030, it is 100%. You just can't make it after 2030. So we have a few years of it left giving us data, but it has brought us so much data. Voyager 1 is just phenomenal, and I think Jennifer can give us what is the distance to Voyager 1 from Earth right now. We have a live feed of that. She might be able to bring it up, but what's the distance?
The distance currently is 152 AU, which in miles is 14 billion, 145 million, 123,000, around 860 miles.
Okay, so I don't know. I would just like to call that far, if that's possible. it's really far away. Voyager 1 is crazy, but we can make it a little more simple. You guys know that you've probably heard of speed of sound. If you're far away and somebody, say a track meet, and they shoot the little go gun, you see the smoke come out of the barrel, and then you hear the shot moments later. Light obviously has a speed limit too, 186,282 miles per second. And because it is so far away, if you divided that into the distance, 14 billion, is that what you said, Jennifer?
Yes,
14 billion
miles.
It's going to take 20, what is the distance? 21?
21 hours.
21 light hours away. Not light
Yep.
year, but light hours away. What that means is if we wanted to get Voyager 1 to turn around, like send it a message, hey, can you turn around? We would tell it and send it, and it would take 21 hours before Voyager 1 could get the message. Then it would turn around and send a message back saying it turned around, and then we'd have to wait another 21 hours to get that message back. So this is just crazy. We're nearly one light day distant from Voyager 1. It just blows my mind. Anyway, let's jump into this. Voyager 2, this mission is so special to me. I'm excited to talk about it. This one means so much to me. So let's jump into Voyager 2. Voyager 2, it did the more in-depth readings. So Voyager 1 passed through the solar system stuff, hit up the big planets, and just kind of brushed through. Voyager 2 took a more of a deep dive approach, and literally a dive, we'll get into later. So Anyway, it has much closer passes to the moons, studies them a lot better, gets lots more pictures, lots more videos, and we get more exciting details. So after leaving the Earth, it gets to Jupiter, as we mentioned, like 4 months after Voyager 1, and it says we need to do a lot more of study on things like Titan, viewing other moons, and it gets these really cool in-depth videos. And we're going to brush over this, and I don't really like to so much, but we'll mostly because we don't have time, and I want to get to my favorite part of all of these missions for sure. So after leaving Jupiter, it's going to go to Saturn, and it once again does in-depth looks at the planets. It gets up close and personal with them. It gets far closer to the moons than Voyager 1 did. Voyager 2 also, as I mentioned, deep dive. Learning about these weird things on the rings, they decided to take Voyager 2 and pass it through the rings. And by through, I don't mean like there was a nice little gap, let's just hook through the gap. I mean, they just full send right through the rings, just went in there. And as they went through the rings, it got pelted with a whole bunch of these little tiny dust particles that made Voyager 2 have to spend a bunch of extra fuel it didn't anticipate in order to constantly turn itself back upright. It wasn't anything that destroyed stuff, it just made it have to respond. This is just dust. These are not like, it's not getting hit by big old rocks or anything. Just tiny, tiny little micron-sized pieces of dust, but there was a lot of matter there. So it had some effect that they didn't plan for. There's no drag in space. So when all of a sudden space is dragging you down, you got something. Okay, looks like we're going to run to a question from Kurt. He says, there's a company planning on having an orbiting station larger than the ISS with about 4 dozen hotel rooms. It should be built by 2027. Have you heard of this? Definitely I have. I saw that headline, I don't know, a few days ago or something, Kurt, and I was pretty pumped about that. That looks neat. From what I saw, I don't think that Jennifer has any images of it to show us, but from what I saw, it was like rotating. It's going to have its artificial gravity. I don't know if you can confirm this, Kurt, but it looked like it was going to be one of those artificial gravity space station things that's going to be rotating, and we could get some Space Odyssey stuff going on in there. Sounds, I'm super pumped about if that's possible. Lots and lots of people though, Kurt, I'm sure you've seen this, but so many people all the time they're saying, we're going to do this by this date, and it doesn't work out. People like Elon Musk and others are really pushing that boundary with their companies. So hopefully, I mean, I would love if that does come true. It's one of those things that people like us, we don't ever get to see. But I guess we get to see videos of people there, you know, that have silly amounts of money. I don't know. Anyway. Yeah, I'm excited about it, Kurt. Thanks for the question. Brexton also asks, can we ever get data from those missions out of the solar system? Definitely. They have, I think you can see behind me, Voyager has got a gigantic dish on it. Also, reservations, yeah. Also mentioned, that I didn't mention, one of those behind the scenes, you know, people who paint and build the sets at theaters, is while they're sending these Voyagers through space, NASA was actually developing something called the Deep Space network. It's called Deep Space Network. Yeah, that's what it is. Giant satellites all over the world. I think there's some like in Spain. We have them in the U.S. Just these huge satellites so that they can talk to these spacecraft as they were leaving. So in the later years, I think they finished it. We haven't got to it yet, but when this gets to Uranus or Neptune, I think they finished the Deep Space Network. I have to double check on that, but yes, they were definitely able to communicate with it, Kurt. Brexton, and we got a lot of data back. The images we showed you were from that, so we have some more images to show you when it gets to the outer solar system that were just also game-changing and just absolutely remarkable. Anyway, it flew through Saturn's rings, and then in 1982, Voyager 2 begins its trek to Uranus. So we're on our way to the most joked about planet. No doubt about that. I mean, on normal circumstances, without the pandemic, my job is to make these butt jokes in the planetarium to get laughs for people, you know, so they're interested in space. But what people don't often know is that Uranus actually, when it was first discovered, they named it George. So it could have been worse. I think, can you imagine the planet George? All right, we're going to talk about George. It's ridiculous. They did rename it. It was named after the King of England, George. Obviously, people didn't like that guy. We didn't, Americans anyway. Anyway, picture of Uranus. Now, these pictures that the Voyager spacecraft were sending back were so high res for the time. They were so game changing that they became the staple images of these planets. Such a small little image of Uranus here, taken in 1982. Sorry, 1986. It took 4 years for it to get from Saturn to Uranus, but photos taken in 1986. These images were so game-changing that they became staple for decades to come. If you go out to a museum today, you buy a picture of Uranus, there's a good chance you're going to see this one right here, this particular image. When it got to Uranus, this is actually when we discovered something that most people know. Uranus is on its side. Hey, its magnetic poles are at its equator. That was really weird for NASA to see that. They also discovered that Uranus is just like insanely cold. It is the coldest planet, not Neptune. That's a little wacky. Yeah, Uranus is very, very frigid. Not sure why. Saw some moons. Discovered 11 moons of Uranus. The tilt, and then in 1986, after it gets there, you know, immediately it's just a flyby. It pushes on to Neptune, and my favorite photo. So we're going to get to that. Don't switch it just yet, Jennifer. Let's answer these questions. Braxton says, want reservations? Definitely me too. Kurt says, I believe so. Artificial gravity, and it did remind me of a space odyssey. Yeah, that's all I saw was him running inside. In my head, I just saw that and just kind of laughed myself. It looks enormous, that space station. When can we get back inside the observatory for more science? Well, Brexton, I have some halfway news for everything you said. The observatory, we do have an observatory. Levent and I are back out there working on it. We hope to get that open. That was outdoor space, so we may end up opening something like that open sooner than the planetarium to the public. But the planetarium, we still have no word on when we can let people back in. We want to, if we do it, we want to make sure that it's safe. We want to make sure that people feel comfortable coming into the planetarium. Yeah, but there's no doubt, Brexton, that I want to get the planetarium back open. I love this place. I love doing shows and programs for people, so I can't wait. I want to mention, since we're here, I think our link that we can post is donate to support to the planetarium. Don't feel like you have to, obviously, but every little bit helps, as we are now gone almost an entire year without public programs, and that's a big deal. Usually this time of the year, and Jennifer can attest, I'll see 1,000 kids in here in a single day. And that's brutal. And when you do that all through March, every day of the week, you get 1,000 kids in the planetarium. Yeah, we don't have that this year. So all the support helps. We'd be super grateful if you could do this, but I'm throwing it in at the late middle of the program because it's, you know, we're not sticking our hands out for people. We're just making sure you know that there's something there. Anyway, Kurt asks, does Uranus have anything comparable to Titan as far as anything Earth-like? So Uranus has a moon called Titanus? Why does this slip my memory? Triton. Triton.
The other blue moon.
The other blue moon. Yeah, Triton is an interesting moon. It's another ice moon. But because it's so far away, I don't know how much we know about it. Is Triton actually Neptune? Can you confirm, Jennifer? She'll get that information for us. I'll check on that. But it doesn't have any moon that's as cool as Titan. Titan is by far the only thing we're aware of that's like that. I mean, it's a gem in the rough, right? Super cool.
It is the largest moon of Neptune.
No, I was wrong. I'm gonna go out on a limb and say Uranus has no cool moons. I should get some flack for that. Levin's gonna watch this video and come after me for saying that. Anyway, yeah, let's move on from here. So let's go on to our next planet. It leaves 1986, and it arrives at Neptune in 1989. And we get to see this picture. When I was a little kid, I was pretty pumped about space, so I saw this. It's like a magazine insert that comes out when you buy magazines, and it said, send us information, and we will send you, I don't know, like an information packet. It was basically NASA saying, hey, we have this stuff to send out to the public. So I wrote them the letter and included in there that I wanted to know about the solar system, and they sent me this packet of whole bunch of stuff. It was actually amazing that they sent this poor kid who lived, in the middle of nowhere, this big packet of pictures, and this picture was one of them, along with the last picture and the picture of Jupiter and the picture of Saturn. I had all of them, and this photo just blew my mind. Blew, pun intended. We saw one thing that was really fantastic. First of all, the dark spot, the great dark spot. They'd never heard of it. They'd never seen it before. It was the first time that they were able to really put their eyes on it. But this was cool. It was a vortex that allowed them to look into the atmosphere. They were to learn so much about the insides of Neptune, but also it was another great spot or a great storm in the solar system. So it was kind of making NASA think, maybe we missed one on Uranus. Does Saturn have one? And I saw this picture and I was blown away. This was like such a neat photo, so beautiful. Blue is my favorite color, right? I was attached to it. And what I didn't know is that after leaving Neptune and heading its way out of the solar system, Voyager 2 went on about its business. I didn't know that people went looking for the spot again. And in 1992, you guys know the Hubble Space Telescope, well, it turned itself on and looked at Neptune, and the great spot was gone. So I lived probably 22 years before I discovered that the great spot was gone. Storms on Neptune come and go, and they do their thing. So we got Brexton. Is the oval shape on Neptune a crater? It's kind of like a crater. It's a bit of a vortex, yeah. So in a way, it has a hole that you can kind of see down in it. It was pretty fantastic. Thanks for that question, Brexton. Anyway, yeah, Voyager 2 heads off on its journey. Now, both of these spacecraft at this point in time have left the solar system. They are confirmed having left the solar system. We expected that. NASA had planned on that. They had anticipated that. They hoped nothing was going to go wrong and these spacecraft were going to continue forever. And because of that, they attached to the spacecraft a beautiful plaque and a golden album, which we'll get here. There we go. On the spacecraft. On one side, it has this stuff, and then the other side, we know it. We don't have a photo of it, I don't think. Maybe Jennifer can get lucky and get one. But we attached Sounds of Earth, which is has a bunch of music. It has people saying hello from, I don't know, an incredible amount of languages on it. It's really, really neat. But let's talk about this. This is an iconic image, absolutely beautiful image. Most people don't know what it is. I want to see if we have anyone in the comments can tell us what it is. Any guesses? I mean, I'm going to tell you, so if you don't guess, it doesn't matter, Braxton or Kurt, either way. But this is actually directions. It's a map. It's how you find Earth. On the upper left-hand corner here, we have this kind of cool circle here. This is them kind of explaining how to read the map. This is binary code that defines information about a hydrogen atom. So, this is, I'm getting ahead of myself. This is how to read the record. As a normal record, like we have a record player here today. Anyway, moving over, we're going to talk about this image right here. Jennifer, I can't see too well. Awesome, perfect. Okay, so this diagram defines the video portion of the record. They put some video on there. So we have how to listen to the sound or how to open it. And then we have how to see the video. And then moving down, we have some other little lines. You talk about how to scan the code and where stuff's going to be triggered. Just kind of boring stuff on how to read it. And then a little farther here, we have this box. This is the frame that shows how it should be scanned. This up and down arrow. Just how to read it, what it should look like. Let's go to the other side of the album over here. This is a little tough for me, you guys. Green screen, first time. We have this huge little map right here. This diagram actually defines the location of our sun, and it uses 14 pulsars that are in our area to try to help point to where we are. So it shows 14 lines that bring up each of the pulsars. And then down here, this little bit, this is the diagram of the low states of a hydrogen atom. I got a little ahead of myself earlier, but anyway, super cool way to show it. This is humans thinking, what's the most obnoxious way we could write a roadmap in space? But really, I mean, you got to think these people aren't going to speak English. They don't have any clue how to read our stuff. Very, very neat. Anyway, you guys, I wish we had more time, but I've already went far longer than I could have. So if you have any questions, you can drop them in the chat, and we'll kind of get to those, and then we'll go ahead and end it for the day. Looks like we got something from Brexton. He said, I think they have Reddit with all the new sightings of UFOs the past months. What do you think the pilot saw above his plane? Yeah, I did see that recording. I don't know what to say. I mean, UFOs, I think the description of that word is how you should best describe it, right? Unidentified flying object. We don't know what it was. It could be a cool phenomena, maybe some kind of physical phenomena we don't know. Could be somebody else's plane. Maybe Russia is testing like a, I don't know, hypersonic. What did we say, Jennifer? What's a cool aerospace? You guys don't know Jennifer too well. She hasn't shown herself, but she's actually an aerospace engineer grad student here at UTA.
Yes, the camera's not working, but there are hypersonic missiles. Most likely it was a missile
Wait, hypersonic means what?
faster than Mach 5, which means 5 times the speed of sound. So pretty fast.
Do they put humans in those? Have they put humans in anything above Mach 5?
Technically, if you count rockets, yes, but nothing like missile-wise.
I mean, once you go into space, the Mach thing doesn't count, right?
Yeah.
Yeah, it's only some kind of atmosphere stuff.
To
sound is always
help,
confusing.
when the space shuttle comes back, it can reach speeds of Mach 25. So pretty fast.
Kurt, have you discussed Room and Twitch? We did. Looking at university policies and guidelines, they want us to stick to Facebook. I do agree with you. It could be fun, Kurt, streaming on Twitch. I mean, there's more ways for you guys to interact and so on and so forth. We could turn on Facebook gaming and also have a lot of those interactions be similar, but right now we're sticking with Facebook because university guidelines request, hey, we really like it if you guys could, I don't know, I think Facebook has more stuff for people with disabilities, more ways for us to expand on that, add closed captioning, so on and so forth. Maybe they're just not familiar with it, but yeah. Anyway, thanks, Brexton, for that comment. I think we're going to go ahead and end it here for today, guys. Thank you so much for tuning in, and we will see you next week, hopefully with Levent back. See you guys.